you guys are doing well. So, continuing on our, just give me a minute. Hello. Yeah, hello everybody. Hope you guys are doing well. Hello. Okay, so basically we learned about some strategies, right? Just give me a minute. Yeah, so basically we were studying about arrays, right? So yeah, basically we were going through the two pointer ideology. So the first thing that we studied is where we can apply it has to be a linear data structure. So a linear data structure is the one where you have a successor and a predecessor, and there is no hierarchy. You have one single level. Some common are arrays. Then you have, so stacks and queues can be represented by arrays, right? And you have linked list as well, right? That comes under here. Okay. So the first thing that we were seeing is basically what do you say? So in two pointer as well. So there are different types of traversal that we studied. First was inward. Then you have staged. And the last one that we have is basically uh, inward staged and uh, so inward is basically, suppose if this is an array, you start and go towards the center. So you have two, and condition will be cross, or when you uh, meet some specific condition. So this is that the, but then this unidirectional, right? So stage is basically you allow pointer 1 to grow a certain number, and after you meet a certain case, is it, so you have pointer 1 that goes for a certain condition, and then you have pointer 2 that starts. Okay, unidirectional is when both start from one end and go to the end. This is like one direction. So basically this is a two pointer algorithm. So first is so let's see. So the first is, the question says given an array of integers sorted in ascending order, and a target value, return the indexes of any pair of numbers in the array that sum to the target. The order of the indexes in the result doesn't matter. So basically, you have an array given here. Minus 2, 3, 4, 6, and then what they are asking is find indexes whose sum up to whose sum is um, whose sum is a certain target. So first, for example, so let's say that target is 7, right? So if our target is 7, then the two numbers that add up is 3 and 4, right? So 3 and 4 is 7. Then we need to return the indexes. So this is 1, 2, 3, 4. So you can return 2, 3 or 3, 2. That doesn't make any difference. Both are the same. And then you need to be this has to be an array. So what would be our approach? Okay, first let's see the brute force. Our always goal has to be, what would be brute force? So brute force is yeah. So we know if it's brute force, I can access only one element. So one element can be accessed, right? So for example, brute force is you take -5 and go to the end. Like from -5 you go to the end and check if sum is equals target. Now repeat this process. So repeat these things n times. So this is going to be n times n, right? So basically this is, so the brute force approach is going to give me n square time complexity. Now the thing is, we want this to be done in a linear fashion. So the moment we say about linear fashion is we have to think about two pointers. So we are going to think about using two pointers approach, and then let's say in 2 point you have inward, you have uni, and you have stage dot step. Which traversal would be effective here is what I'm trying to understand. So -5 -2. Okay, now which traversal? Hmm. The brute force is possible checking. This is done using two nested loops and auto loop that traverses the approach. And okay, we saw that. So we saw the code as well. Now the approach has an O of n square time complexity where n denotes the length of the array. Here we do not take into account the input array sorted. We could use this fact. So we have one thing in our with us, right? Input array is sorted. So we have something called as, so we have this um uh so we have this thing with us. Now what's the advantage of having a sorted array? Mhm. Okay, so remember, elements to the left are smaller, elements to the right are greater. So how could we use this? Like which traversal should we use as the condition we are trying to say? What we could do is, suppose let's try invert traversal makes sense, and the whole point is whenever you are using invert is when you have what do you say, some sort of some crossing condition comes in. Condition or crossing, okay. So what we could do is, suppose if we do invert traversal, so that means, suppose we use two pointers, right? So what we say is one pointer is over here and one pointer is over here. Now minus 5, remember, this is the target, right? This target. Okay, what if, so let's suppose say we add minus 5 plus 6. Minus 5 plus 6 is going to give me 1, right? Is it equal to the target? No. Then what we do is, um, 6 is at the end, right? So like this is the smallest and this is the largest value. If this smallest and the largest value are still not equal to sum, what we do is we can move to from the left. So let's say let's do minus 2 plus 6. This is still not 4. So then we move further. We go to 3. 3 plus 6 is 9. But what if we, like, where have we to break it? So my 3 plus 6 is 9. This is going to make the target greater than the, we are going to get a value that is greater than target, right? So if we get anything greater than target, then I guess that is the breakpoint. That is the breakpoint, I feel. Now, since it was less than a target, we need to move one of the pointers to find a new pair with a larger sum. If you are getting a number greater than the target, then move inwards. So let's move inwards. So then we do 3 plus 4. So this is 7 and this is the target itself. Okay. But there should be some other approach. One more thing that we can do is, since A plus B is going to be my target, like we know what our target is, right? Here we are checking in this is we are checking condition. So basically he's trying to cross. Can we cross it? Is what he's checking. There should be one more approach. Eyes. This is like one approach. What could be other way? Is there any other possible? One more approach will be this way. What I can do is, but then this is okay. Yeah, since there are only two. Okay, so the number of unknowns can be thing. What I can do is I can say A is going to be my target minus B. Suppose I'm doing only one this iteration. Okay. Right. So I have this array, right? Minus 5, minus 2, 3. No, I know this, and let B be one's pointer. So what I have to do is, oh, I can do this as stage as well. I feel that. Um, so what if I do? So suppose I take this is 5. So 7 minus a minus 5. This is going to be 12. Do I have 12 in this array? Do I have this? Is the question. Comparing one single will be O of 1, I guess. O of this is O of an operation. So this is I guess staged. You can stage it as well. We are waiting. Okay, so then we increment it and again we search the array. Yeah, we could also do that stage thing, I guess. No, instead of uh there is one more way. What if I do my target is oh wait, B is equal to, is this also going to give me, if I do without hash, I guess it's going to be but isn't that the same thing of finding A plus B? Yeah, this is also the same as doing A plus B thing, right? This is also going to be, I guess, O of n square only. The reason why, okay, let's see. Let's draw something. So this is my stage. What I do is I fix A over here. This is A, and then I have some. What I'm going to do is first I'm going to subtract. So I'm going to do B is my target minus A, and then search B. This has to be repeated uh, for every element, right? So this is going to be done and like array length size. Okay, and then search will be also performed, right? So this is again same thing, O of n square. This actually this approach is nothing but staged approach. You fix one thing. What you do is you fix one, say A is over here. Let B go through every element in the remaining part. So let B be from here to here. This is basically staging only. So if I don't use an hash set, then it still gives me so there is so that hash thing. Unidirectional is need more this on unidirectional. So in one although unidirectional and stage traversal come very similar though. But yeah, without hash the yeah, when no hashing becomes, then it's the whole point of unidirectional is you visit only once. I mean, this is the visit only once ideology. So we haven't seen that. We'll see. Next is basically triplet sum. Basically three values summing. Now here that A plus B plus C won't work. That ideology is basically we need to find where three values together give up sum and they give up a target. Let's have an array here. So this is 0 minus 1 2 minus 3. So basically we need to find these three pairs. Okay, the brute force. Yeah, let's go with the brute force. How will the brute force work? So we'll be needing 3 pointers, right? Here 1 2 and 3. So I fix one. Yeah, possible. Find all possible combinations, right? So whenever I fix something, this is like staged. And move the other two here. Move the other two till end of arrays. For example, for 0, so this is like for 0. First I'll check 0 minus 1, 2. Then I'll move this forward, right? So it will be 0, 2 minus 3. Then it become 0. Okay, so this has to reach end probably. This has to reach end. So once this is gone, then I move the stage again. The other, this is 1, 2, 3, 4, 5, 6, right? So 6. How many possible combinations are possible here? 6 ER. But each combination has 3, right? Mm. This is one set. Other is going to be say minus 1, 2 minus 3. Then you have minus 1 minus, okay, this is one set. Okay, and then we go to 2. So 2 I have only one possibility. 2 minus 3, 1. This is 2 minus 3, 1. But then there is no left only. There should be that 3 thing available, no? It's equal to target. Okay. 63 is uh, 6 factor. I forgot. What is how many? How much is uh, 63, right? Oh, yeah. And then no repetitions. Repetition not allowed. The first one is going to give maximum possible, right? Then 1, okay, 1, 3, 4, 1, 5, 6. Then you have 2, 3, 4, 2, 4, 5, 2, 5, 6. Then you have 1, 2. But 1, 2, 4 is not taken. Oh no, I'm not considering this. Yeah. No, wait. No, this I'm missing some combinations here. Yeah, so what do is for fix this and then you both from this to this, right? And then going till n -1 to then increment this, reach end. Then again you increment to -3, 1. Then again you increment -3, 1. And then when last is triplet, there is nothing, right? So first is you fix this, then in second is you fix over here and let this run till end. Okay. So this is already 2 loops and then already 3 loops. So already a O of n cube we have generated. Not a very good approach. We need to somehow come to O of somehow like linear. Yeah. Can we do better? But this array is not sorted. Oh yeah, this is non-sorted. So condition is it's non-sorted. So here we can't do inward traveling. Let's see what better way we can get. What is the better way? We know one thing, right? This is our target. So A is equal to the sum of these two. How can we reduce our iterations? You are checking all possible combinations, no? Since there is no sorting, so that 2-pointer inward traversal automatically is lost. No, I'm not. Did I? Is this the brute force? Like find all possible combinations. Which loop can I eliminate? Two sum can be done in O of n, right? Two sum. Suppose if I want to find two values that sum up to a target, this I can do with O of n. This can be done with O of n ideology. But if it's sorted, right? But for this you have to sort to be able to apply it to O of n and introduce it. The whole thing that we have to think about is in array brute forces, suppose having three loops. Is there a way we can get it to two loops? This should be the thought process. So what if we say that we fix, suppose we do target minus a number. So p plus c is equal to, yeah. So then now this is coming now to two pointer situation. This is two pointer. This has come down to two pointer, right? It will be n log n, something like that. Complexity, because first we'll have to sort as well, right? because once we get that two pointer, we can. I'm trying to understand the ideology. If from brute force n cube we want to come to n square or lower. Yeah, all possible combination is. But the thing is, all possible combination is also working for duplicate. We haven't thought about. But here is that when we find one pair, we break out, right? No, but in two pointer, do we find all possible pairs or we just find one pair? In that I guess it says okay of any pair of numbers. Yeah, even in two pointer it's but that is only given one pair. We didn't think about this. What if we have more than one pair? Like what if we are have repeating values? We didn't say that case. Okay, yeah, that's all for the session. I hope you guys liked it. We'll continue with another session and then we'll go on from there. Yeah, that's all for this session. Thanks. Bye. Take care.